Okay, recording right now. So let's start from the top. We're going to redo synthetic division. Synthetic division only works, so you can put a little asterisk next to it, when it's x plus c. And when I say x plus c, that means the coefficient of x has to be 1, and the power of it is 1. We also call this a linear binomial, or not even a linear, yeah, it's a linear binomial, where it has two terms. Okay, so it has to be that kind of way. And c could be any number, positive or negative. It just has to be a constant. All right. So how we're going to start this off is that we're going to take the x minus 2 and we're going to flip this sign into positive 2 and we're going to put it here. And we're going to make a long division symbol, but instead of it being upside right, it's going to be upside down like this. So we start with the number in the divisor, or the constant divisor as a flip sign, and you're going to flip it over like this, the long division. Now, the numbers that go inside are going to be the coefficients of these numbers. You got to start at the highest power. So x to the fourth, the coefficient of that is 1. Now you want x to the third, but you visually do not see x to the third, so that means it has to be multiplied by 0. So x to the second, which is a -2, x to the first, which is a 4, and x to the sixth, which is a 1, or x to the 0, which is 6. Now, how we're going to do this is not like division as typical. It's kind of like reverse. And this is where my big mistake was. So what we're going to do is first, we're going to start off by bringing down 1. You just bring down unconditionally whatever the first term is. Then you're going to bring the number up here. The number that's going to appear here, it's going to be this multiplied by this. So your divisor multiplied by what number you just brought down. So in this case, 2 times 1 is going to be 2. And instead of subtracting like we do in normal division, we're actually adding. So there's a lot of reverse. We're multiplying and then we're adding. Bring it down. 0 plus 2 is 2. And now we're going to bring the number up. It again, divisor times the new number. So 2 times 2 is, in this case, 4. -2 plus 4, you add it. -2 plus 4 is going to be a +2. Once again, multiply it with the divisor, happens to be a 4 once more. 4 plus 4 is 8. Multiply it with the divisor, which is 2. 8 times 2 is 16. And 16 times 6 is or 16 plus, I apologize. 16 plus 6 is going to be 22. Now, how are we going to write our answer? So x fourth was the highest power. We're going to bring that power down by 1. So this power is x to the fourth is going to be x to the third. This is a +2, so plus 2x to the second plus 2x to the first plus, this is going to be our constant, 8, plus this is going to be our remainder. And this remainder is going to be important, and we'll see in the next section. This remainder is going to be important. So that's going to be 22. I don't know why I wrote it there. 22 over our original divisor, x minus 2. And so I just, go ahead.
But it's not x to the fourth, so how come we're starting with x to the third in the answer?
Yeah, because you're bringing it down 1 power. Remember, you're actually technically dividing it by x minus 2. So this x will bring all the powers down by 1.
Got it. All right.
So your divisor has to be...
Excuse me?
Go ahead, Sarah.
I'm not really sure. So so like for the table, so you're, I'm not really sure what you're doing. You're doing what
Are you not
exactly is
sure
happening
about
here?
this row?
No, the row after it.
This
How
one.
did he get that?
Okay,
Mhm.
no problem. So what we do is the first number I get, the first number, it's just this brought down. So I brought it down here, which is 1.
Mhm. It's from the coefficient of x to the fourth, right?
Yes. Now, I'm going to take
Okay.
this number, which I just brought down 1, and multiply it with my divisor, which is 2. 1
Wait, where
times
did you get the 0 from?
this 0,
Where's the
that's
0
x
from?
to the third,
Mhm.
but there's no x to the third, so we have to put 0 in this place.
Oh, I see.
Okay. Then 1 times 2 is 2. Bring down the 2 plus 0 is 2. 2 times 2 is 4. Negative 2 plus 4 is 2 again. 2 times 2 is 4. 4 plus 4 is 8. So you add down, you multiply to get the new number, and then you add it down. Okay? Multiply up, then add down.
Wait, you multiply up, then add. Wait.
The red, here. The red, multiply up. The green, you're adding down. Red, you multiply with the red number here. Green, you're adding down. So you add.
I'm not. What?
Why don't we do another attempt, Sarah?
Okay, yeah.
Okay.
Mhm.
All right. So I have this other one right here. Everyone copy it down. I want to give you guys a minute. Try it yourselves. And then I'm going to go over it. If you are trying it by yourself, send me a private message of the remainder only. You don't have to give me the full answer. Just give me what your remainder was, the numerator at least. If you get me the remainder, I could figure that you did the rest correctly.
Mr. Koval, are we going to have to assume that there's an x to the fourth, or are we just starting at the highest x?
Say that question again. You were a little low.
Like the way that it is in the first problem is like there's the x to the fourth, and we assume that there's the x to the third. But are we just starting at the highest one here, so we don't?
Yes. So in this one, we're starting at x to the third. And then you see there's no x to the second, so you have to assume that x to the second is going to be 0.
Why are we using -2?
Why are we not using -2, or why we are using -2?
Yeah, why aren't we?
You got to think of it like, you know how x minus 2 equals 0? So x equals actually positive 2. That's kind of why it's it. Hannah, you got it. Good job, Hannah. So just send me the remainder, like the numerator of the remainder, or your last number on this thing, just so I could check. I'll set it up for everyone silently while you guys work on it. Lexi, yes. Mitch, check your adding. You might have added something wrong. Something went wrong there. -13 plus 16, or -13 plus something. Anna, good. Nate, good. Brandon, Haya, and Rebecca, good. Jacob, I think you actually typed the extra 6, but I'm going to assume it's but Mitch, David, Shoshana, good. Okay, so let me just go over one more time for everyone. Good job. I'm seeing a lot of good answers. You'll see, no, not 8. Let's see what happened. Okay, so I'm going to bring the number down, which is 4. Dylan, good job. Now, what I'm going to do is multiply the number 4 times 2. That's going to give me a new number, which is 8. Then I add vertically 0 plus 8. you'll see not 12 either. So 8 over here, 0 plus 8 gives me 8. Once again, 8 times 2 is going to be positive 16. Negative 13 plus 16. Negative 13 plus 16 is going to be positive 3. Again, multiply the 3 with the 2. You're going to get a 6 in this case. 10 plus 6, 16. So your final answer would be, this was x to the third originally, so we're going to bring it down 1 power. 4x to the second minus, oh no, I'm sorry. 4x to the second plus 8x plus 3 plus 16 all over x minus 2.
Are we able to use this as long division?
Yes, but remember, it only works if it exactly is a, like this kind of binomial where x is a coefficient and the power of 1.
Okay. Thank
Okay,
you.
no problem. So that's what we can do. Now, because it's so good question on that, can we use this in place of long division? Yes. But in this situation, like other than a very specific long division, why is synthetic division useful? So we're going to see why synthetic division is actually very useful. So we're going to the next page. Does anyone have any questions on this page? Okay. So why is synthetic division actually very useful? So what we're going to use is called the remainder theorem. So you could just title this remainder theorem and write the problem. If you want to write that whole sentence, that's fine too. Okay. So the remainder theorem basically states this. How can I write this? Okay. If f of x, so some function, is divided by x minus k, so some monomial, kind of like what we had, yes, like the last problem was x minus 2, so x minus k. You could use c it also. Then the remainder so the remainder, as in our last term, is r equals, r being the remainder, f of k. Yikes, f of k. In English, what does that actually mean? That means that if we plug in for synthetic division some value k, we'll get the solution as if we plugged in the number into the equation. So plugging in for synthetic division 3 will also solve me for the answer 3. So I'm going to show both of me plugging it in and then using synthetic division. So first, just plugging in 3 into here. So if I said, give me what f of 3 is, it would be
Is
3
synthetic
cubed.
division-
Go ahead.
Is synthetic division only x minus k, or it could also be x plus k?
It could be x plus k, but it's just telling you like you're doing the negative of it in this specific thing.
Oh,
Kind of like how I
got
mentioned
it.
earlier. You said like, why not negative 2? It's because it's still negative.
Right, got it.
So -4 times 3 squared plus 2. Now in this polynomial, it would make sense, hey, maybe just plugging it in would be faster. 3 cubed is 27. -4 times 9 would be -9, 36 plus 2. So that should be -9 plus 2, -7. So if we were to plug in this, we would get -7. Now in this polynomial, very particular polynomial, right? It might be easier just to plug it in, but sometimes it'll be easier to put synthetic division, particularly when it's like a really long one. So I'm going to use synthetic division to prove that we'll also get -7. So to set it up, we're using the opposite. So technically what we're doing is we're dividing this original equation by x minus 3. We're technically dividing it by x minus 3, but we're just using the synthetic division to our advantage. So because it's x minus 3, I use the opposite, plus 3. I'm going to put in the terms here. X cubed is 1. X squared is -4. X to the first power doesn't be seen to be seen, so we're going to put 0. And then x to the 0 power is 2. Or you could say the constant is 2. Bring down the 1. 1 times 3 is 3. 3 plus -4 is -1. -1 times 3 is -3. -3 plus 0 is -3. -3 times 3 is -9. -9 plus 2 is 7. So the key part about the remainder theorem is that this number right here will always be the answer if you did f of 3 will always be your remainder, which happens to be in this case 7, but that would apply to any equation. So sometimes when plugging it in would be too cumbersome, synthetic division could lead to an easier version of the same type of problem. All right, does anyone have any questions on that?
For the x equals 3, that's referring to the k, not specifically the x.
When I say, yeah, the k, we're using it in place of here. Like we're technically we're doing divided by x minus 3 and using synthetic division. Or you could have used long division in this situation. But what we really care about is what is the x value at 3, and we could use synthetic division for that. So the k value is whatever my input is, my specific input, I should say.
Yeah, but in the question it says x equals 3, that 3 is what we're plugging in for k.
That's true. If we're plugging, so when it says x equals 3, it's like you're plugging in 3 into here. But
Yeah.
when we solve it, we're trying to plug in f of k, which we want to be f of 3. So yeah, we're plugging into k, if that's what you're saying. Absolutely.
Yes.
Yeah. Okay. All right. We'll go to the last part of today. I'm going to the next page, guys. All right. All right. Show that x plus 4 is a factor of this polynomial. Then find the remaining factors of f of x. So I'll let you write down this problem. So then you have your notes. As you write, I'll talk to you though. So when we have a remainder, what turns out is that you have some value at it. Like in the previous question, when you plug in 3, you got out -7. But what if you plugged in something and you got exactly 0 as your remainder? Well, that would provide or prove that that would be a factor of this equation. So what we're going to do first is simply, or first I'll write down that official rule. If f of x has a factor of x minus k, notice similar setup as the last question. And f of k, it should be k, f of k equals 0. Oh, I'm sorry. If f of k, I'm sorry, if f of x has a factor f of minus k, then I should say, then fk is 0. So if this is a factored form, like if we were to factor it out, like whatever way we need to factor it out, then f of k would equal 0. Kind of the same way you would have like x plus 4 equals 0. So you would figure out that that would be a factor of it. So let's do this problem actually then. So we're going to first synthetic division using x plus 4. So we're dividing this polynomial by x plus 4. Doing so, we have to take the opposite of this. So it's a plus 4. It's going to be a negative 4. Then we set it up. 1, negative 28. No x to the 1 power, so 0. Negative 48. Okay. So I bring down the 1. 1 times negative 4. Negative 4. Negative 28 plus negative 4 is negative 32. Oh, my fault. My fault. Rewrite this question. There's an error in the question. This should be, and I apologize for this. This should be x cubed minus 28 x to the first power, no second power. Otherwise, this answer wouldn't work, or at least this factor wouldn't work. And I apologize for that. This is I just got this one off from the drive. So x cubed minus 28 x to the 1 power minus 48. So our setup would be 0, negative 28, and negative 48. Because otherwise our numbers get too huge and it's very cumbersome for example. My fault. Okay, so refresh. We'll start back here at 1. Multiply 1 with negative 4, that's negative 4. Bring that down, that's still negative 4. Negative 4 times negative 4 is a positive 16. 16 plus a negative 28 should be negative 12. We're going to multiply negative 12 and negative 4. That's a positive 48. And then that goes down to 0. Okay, so our remainder being 0 is very significant. That means that whatever x cubed minus 28x minus 48 factors into, one of the things it will factor into is x plus 4. What we want to do is find the remaining factors afterwards. So since I just divided x plus 4 from this, what I'm left over with, it was x to the third was the biggest power. x to the second minus 4x minus 12. And we're going to set that equal to 0 to find the factors of this. So the original question, we're just bringing it down here. So x squared minus 4x minus 12, let's factor that out. We could physically factor this out very simply. Again, you could spend time doing synthetic division or long division, but there's no point here because you could actually factor this out normally. So things that multiply to negative 12, that add to negative 4, negative 6 and 2. So we have x minus 6, x plus 2 equaling 0. So we just factored this out. Adding, or I should say multiplying, the one that we divided for, x plus 4, these are factors. The factors of our original equation, which should have been x cubed minus 28x minus 48. And I apologize, we're basically out of time. But I would say if you were to FOIL this back out, if you FOILed this answer out, you would get back this original question. And I would love to show you, but I think we're out of time. So guys, anyone who is here, I'll take any questions, by the way. But if you want to go, because time's up, type here and you're free to go afterwards. Again, thank you guys for being patient, no problem, with my technical difficulties, and have a wonderful day.
You too. Bye.
Bye-bye.
Bye. Wait, are we going to have homework?
Yeah.
Okay. Bye.